Hey everybody, we're going to jump into some new content today. So, this will be our first foray into new content. So I'm going to keep it slow at the beginning just to everyone can get a chance for the beats here. Then if we need to, we can speed up or slow down. But for now, we're just going to look at topic 7, lesson 1. So I'm going to kind of take the rest of the content in terms of importance since there's no real sequence. So we'll probably do topic 7, then jump back to topic 6, and then maybe tack on whatever we can from topic 8. So this will be kind of our foray into Pythagorean Theorem. So probably a name that you've heard before. And we're going to tack on some content to this. So we'll start with kind of like an exploration. What is Pythagorean Theorem? Then we'll get into kind of applying it. So we'll use it to find the hypotenuse. Don't worry, we'll go over this terminology later. So we'll fill all that in and then finding the leg of a right triangle. So to start, I'm going to do this in a little bit more of an engaging way for the book. So you'll notice I'm not really going to do example 1. So I'm going to do this kind of a different way. So we've got a right triangle, and we're going to go with some terminology so we all know what we're talking about. Well, some shared language. But what do I mean by a right triangle? What I mean here is is it exactly a right or 90-degree angle? It's exactly perpendicular. So could not be more opposite, like streets crossing each other. So we've got our right triangle, and I'm going to go ahead and label the sides of this. So we know it's right because it's got a right angle. And we'll call these two sides legs. And we've got kind of a longer one. This is a longer leg. So this we'll call the hypotenuse, or the longer leg. And just in kind of general terms, it doesn't really matter if you go A here or B here. We'll call this like leg A, leg B, and hypotenuse we'll label as C. So in general terms, as we kind of refer to these, we'll think of these as A, B, C, and we'll kind of signify that this is right, even if you draw it a little off. As long as you draw your little box here to say that's a right angle, your diagram kind of shows it is a right triangle. So the whole name of the game here is we're going to try to figure out how A, B, and C are related. So I'm going to bring up a video for this because I think it's a little bit more engaging. So if you've ever seen the British show QI, this might seem familiar, but you've got this weird box behind them. And if you look a little closer, what you should be able to find is we've got actually kind of a hidden right triangle here. So pretty similar here. And if we go through, we can kind of label it the same way. So I could put A here and B here. And of course, the longest side always has to be C. So A and B can be interchanged. Doesn't matter for that, but make sure you got C as the longest side. So we got A, B, and C. And now I encourage you to kind of pause the video or maybe think as we go along. What are these? So why is this filled with red? Why are these completely empty? Kind of a weird setup they've got here. So kind of a little bit of mystery to this. So I'll go ahead and erase, and I'll skip forward a little bit. So he's kind of going, he starts drawing sides or little sort of like measurements here. And I'll kind of fill that in. So what he's saying here, if this is length A, this is length B, and this is length C, we'll sort of do this with the arrows, is what you'll see here is essentially here you've taken this length of B along the side of the triangle, and it looks like you've got an identical length here. So essentially that's interesting. They've got some kind of setup where it's like they've taken the side of B and they've rotated up this way, and so that's almost like a B by B portion. We'll call that B squared. Here we could do the same. If this length is A, this length is also A. So that must make the area of this A squared. So we can apply the same thing here. If this length is C, this is also C, which makes the area of this portion C squared. So they're not relating. These don't really, like the the portion inside here doesn't really represent the lengths anymore. It represents now an area. So interesting. So let's keep going and let's see what happens. So I'm gonna go ahead and clear my screen of these and we're gonna see what happens. So I move forward, he's kind of gesturing, you've got these lengths. And let's skip a little bit forward here. So I'm gonna pause it really quick. So what you'll see now is that there's liquid being covered by this area, and he's rotating it so the C portion, or C squared portion, is now draining. Rotates, and it rotates, and it rotates. So the liquid from C squared is now draining into B squared and A squared. So what I'm going to encourage you to do here is do a quick pause, see if you can figure out what this just signified, and then come back, resume the video, and I'll kind of fill in. So you paused, welcome back. So what we have here is essentially we had this big portion. We called it C squared because this was C, and it was a C by C squared. And again, you can interchange A and B. You'll notice I might interchange through the video as long as you have the two shorter sides as A and B. Doesn't really matter. So we have these area A squared and B squared. And what you found here is if you took the entire area of C squared and you dumped it into A squared and B squared, you would find that these are exactly equal. So essentially, A squared plus B squared is equal to C squared. And if it's a right triangle, that is always true. So essentially, we have our Pythagorean theorem. We know that the side A squared plus the side B squared is equal to the side C squared. And that is our Pythagorean theorem. So let's look at some applications now. So we got our Pythagorean theorem, A squared plus B squared equals C squared. Let's look at some applications. So here, what if you have like an unknown? So this is like we're trying to find the hypotenuse or the long leg of the triangle. So let's write our equation first, and I'll kind of color code it to what they have here. So again, we'll call this side A. We'll call this side B. If you want to interchange them, you'll see you'll get the exact same answer in the end. We'll call this side C. So we've got A squared plus B squared equals C squared. And so essentially what we're going to try to do is we're going to try to find the hypotenuse. So we got 2 bits of information, or actually 3 bits. We've got 1, it's right triangle. 2, we know length A. 3, we know length B. So what we're going to do here is we're just going to plug in our values. We know A, we know B, we're just going to plug them in. So I've got A, that's 8. So 8 squared plus B, that's 15. So we've got 15 squared. And that is going to equal C squared, which we don't know C, so it's going to stay the way it is. So now I've got known value squared plus known value squared equals an unknown value squared. So I've got one unknown variable. I'm just going to go through and solve it. So I'll evaluate the left-hand side. 8 squared, that should be equal to 8 times 8, which is 64. So we get 64. And I'm moving a little quick, so if you're following along, feel free to pause it, evaluate the stuff on the calculator if you'd like. 15 squared, 15 times 15 should equal 225, and that will equal C squared. So now, let's just combine these two like terms, 64 plus 225. Let's see, 4 plus 5 is 9, 6 plus 2 is 8, so we should get 289 equals C squared. And now we kind of use that skill we learned all the way back in topic 1, where what happens if I have to undo a square here? Well, the inverse operation of a square, that's just a square root. So let's square root both sides. And remember, if we square root, we get the positive and the negative solution. So just for completeness sake, we're going to add that plus or minus. So square root undoes the square. And I get c is equal to the square root of plus or minus 289. Square root of 289 is 17. So we get plus or minus 17. And we'll come here and say, well, this is a side length. A side length can't be negative, so we're just going to take the positive value. It's just 17. So we now know that this is a 8, 15, 17 length triangle. And we've solved for the hypotenuse. So again, all you have to do when you have the hypotenuse is plug in a and b, evaluate it out, solve it algebraically. You've got your side length. So now let's look at one more example. What happens when you're given the hypotenuse, you're given the side length, but you need to know one of the missing side lengths. So I shouldn't write b squared, that would just be length b. So we've got Mara here, and she's repairing the trim on one side of the display case sketched. So she has a piece of trim that is 20 inches long, and she wants to know, does she have enough trim to repair the display case? So essentially what she wants to do, she wants to figure out, does she have enough? So it better be less than 20 for this to work. So what I'm going to do here is I'm going to write my Pythagorean theorem again. This time I won't color code it because I think we're kind of getting the gist of it by now. We got a squared plus b squared equals c squared. So let's see what we have. So we've got c, it's 29. If we said this is b, this must be a. Again, you can interchange these. It's totally fine if you interchange these. You can say this is a, this is b, and it'll work just the same. So I'll plug in what I know. I know c is 29. So we got 29 squared on the right side. I've got 20 for a, so that's 20 squared on the left side, plus b squared. And b is what I don't know, but what I want to figure out. So come along here, and I'm just going to evaluate out. So 20 squared, that will give me 400 if I evaluate that, plus b squared, can't do anything to this yet, equals 29 squared. And 29 squared, if we plug it into our calculator, we will get 841. So now I just go through and I solve this. So I want to get to this square, but I gotta deal with this addition first. So 400 is being added to this, or 400 adding to it. So let's undo that by subtracting 400 from both sides. So that cancels out that, and I'm left with b squared is equal to 441. And now we've got the square by itself, so all we have to do is undo the square. So what I'll do here, square root both sides, that cancels out the square, and I get b is equal to plus or minus the square root of 441. And we can just evaluate the square root of 441. That is going to be equal to 21. And of course, this is a length, so here we're not dealing with a negative value. We just got b is equal to 21, and we'll tack those units on as well. So go back, see if we answer the question. It says she has a piece of trim that's 20 inches long, which if this whole thing is 21, looks like we'd probably get to there. So from this, we can definitively say no. This display case was 21 by 20 by 29. 20 inches would not span it. So I want to go back, since this is new content, just show you guys how to find some more resources if you'd like. So if you go to the Schoology page, we'll go to just Math 8. So this is the page you should see. We've got our update section. So if you click materials here, you click the workbook PDFs, I put the remaining sections of the textbook up here. So if you want any more resources on this, you can go here. And so there's an additional example one that I didn't do. I instead showed it with a video, but you can use this to kind of explain what that Pythagorean theorem is. You've got those two examples that I worked out, a few practice problems, and of course you have the practice that I'm posting. So let me know if you guys need anything different. This will be kind of like a test case, how we're going to present some new information, but see if you guys can do the best, and then bring whatever questions you have to office hours. So take care.